Hello students, welcome. And in differential equation of order n, we are going to study that if a function in x, y and with some arbitrary constants are given, then if we want to find the differential equation of this function, it will be of order n. Why? Because if we consider an example x square by a square plus y square by b square equal to 1, this is having two arbitrary constants a and b. So if we want to get rid of these two arbitrary constants, we need three equations. Because we want to eliminate two constants, we need three equations. If we want to eliminate these n constants, we need n plus 1 equations. So you understand this part. So here there are two constants, we need three equations. How do we get three equations? First equation is this itself, we need two more. So we will differentiate it. 2x by a square plus 2y by b square dy by dx is equal to 0. So one more equation has come. It comprises of derivative of y with respect to x. Now we know one more equation. So we will differentiate it further and we will get 2 by a square plus 2 by b square y d2y by dx square plus dy by dx whole square, where we will apply the product rule. We will see this. So basically now this equation is of order 2, their double derivative of y, and we see that now we have three equations, 1, 2 and 3. So now we can eliminate a and b by using three equations. So that is why we say that if we are having a function of n arbitrary constants, we need n more equations other than this total n plus 1 equation. So we have to differentiate it n times, which means that the differential equation of order n will come finally. Thank you students.